Hello everyone, this video will be about filament sensors for FDM 3D printing. Maybe most of you have faced problems related to printer's filament, such as underextrusion, nozzle clogging, and the filament runout. Most of the affordable 3D printers like mine don't have filament sensor to detect such printing faults. That's why we're gonna build our own filament sensor. The first and the easiest option is using end-stop limit switches. When filament goes through this hole, it presses on the limit switch, and during the filament runout, the limit switch is released. However, this sensor can be used only for filament runout protection. Next option is using optical encoders. I have here infrared modules and the rotation disc with some holes. I have built my optical encoder by using two infrared modules. If you use only one infrared module, you can detect only filament runout or nozzle clogging. If you use two infrared sensors, you can track direction of rotation of this disc, you can measure how much filament had been extruded so far, and they can help to detect underextrusion as well. The extrusion components of my old 3D printer was used to build this sensor. The rotation disc is connected to the extruder gear by a shaft, and this shaft is fixed with a bearing, and the extrusion gear can rotate freely. Here's the old video of this sensor, because I've already disassembled this sensor. It worked quite well. You can also see the Arduino output. However, this sensor had some limitations. Firstly, the shaft had little bit wobblings during the print, and they give inaccurate results. The second problem was placement of these infrared sensors. These two sensors should be placed in such a way that time difference when they receive signals should be different for clockwise and anti-clockwise directions. But time to time they lose their correct positions and they give inaccurate results. Next option is using a cheap magnetic encoder. I extracted it from a small DC motor. Here you can see how it's connected to the Arduino. In our case, we don't need motor pins. The encoder A is used for counting, and the encoder B is used to detect direction of the rotation. I removed those infrared sensors and placed a magnetic encoder. It's connected to the Arduino Mega, and you can see the Arduino output. When I push filament down, the values are increasing. When I pull it up, it's decreasing. Let's check our filament sensor. I wrote a Python code that receives data from Arduino Mega and the 3D printer through serial ports. You can see the Python output. It shows how much filament have been extruded in real time according to the sensor data and the G-code data. If the difference between those two data are more than 15 millimeters, the program code should pause the print. I will press this extruder button and release the filament. As you can see, sensor data stopped changing, while G-code data is increasing. Right now it's more than 15, so as you can see, printer is paused. We can continue this print at any time by pressing enter. So that's all for today. Thanks for watching.